Today I am going to discuss a very essential topic, that is conceptual clarity on a topic. When we go to our class, we generally are in hurry to complete the syllabus, and we lack the clarity of the concept behind. It creates confusion in the student about the topic, and it does not create interest in classroom teaching of physics. So I have tried in this module to give some tips on conceptual clarity, how to clear the concept of the topic in the classroom teaching. First of all, we should know about pale blue dot. A video was released related to blue dot by Carl Sagan. This video shows images taken by Voyager 1 on February 14, 1990, from a distance of about 6 billion kilometers. About 28 years back, Voyager 1, which had completed its primary mission, was leaving the solar system. At the request of Carl Sagan and commanded by NASA, Voyager 1 turned its camera around and took one last run of the Earth across a great expanse of space. The first thing is that we should understand ourselves. Who are we? Are we humans, or teachers, or facilitators, leaders, change makers, helpers, servers, or friends of the society? This is very important, that first of all, we should understand who are we. We must understand ourselves. And what is important for us? Is the meetings important? Is the instructions important? Is the deadlines important? Is the assistants important? Is the rules important? Is the policies important? Is the laptops important? What are important for us? That also we should know. And the most important thing is what you are using as a tools does not matter. Change in the mindset. This is very important. How to change mindset towards certain things. First is humanity. We should behave like human beings at all times. Vision a big complete picture of learning objectives. Meaningful collaboration. We should work together with the learners. A sense of belonging. School belongs to class, class belongs to teachers. A sense of priority, and priority should be just now. We should do it just now. Diverse ideas and perspectives. Acceptance to new views, styles, and suggestions. Creativity. All humans have potential, but we must have a purpose. And lastly, measurement, evaluation, self-analysis. So this is very important to change the mindset of the learners. by treating with them as human beings. We should explain what are the objectives of the teaching learning process, and when we are in the classroom, we should work together with the students, and we are present in the class, so there must be a sense of belongingness. What happens, sometimes we teach in the class, students do not bother for that, learners do not bother for that. They are busy in some other works. And never say that it will be done tomorrow or day after tomorrow. Say, do it now. If new views are coming from any newcomers, we must accept it, and time to time, as permits, we should change our styles of teaching, and we should change our suggestions also. Creativity. We have potentials, but we should develop creativity in us so that the teaching learning process will be more effective. And lastly, we should analyze, we should evaluate ourselves. Within the syllabus, learning and working to remain relevant. What you think is important, what interests learners is important, and the common of both is what's relevant. It can be just any content, it has to be relevant, remarkable content. Conceptual clarity. Look at this. A ripples of water have been produced by dropping object on the surface of liquid. Let us think what is meant by concept. What is meant by concept clarity? What is the difference between concept and focus? What is meant by concept and visualization of concept? Why is visualization of abstract ideas necessary? Nikola Tesla, inventor of alternating current electricity, credited his success to his ability to visualize things, to picture them all as real in the mind. Nikola Tesla, if you can visualize what you want as clear as movie, you will understand and accomplish more from it. What is the difference between memorize and understand? Generally, we students or learners use these two things. They either memorize the whole thing or they try to understand. Memory is the faculty of the brain by which information is encoded, stored, and retrieved when needed. It is vital to experiences. It is the retention of information over what for the purpose of influencing future action. Understand, comprehension, apprehension, grasp, grip, mastery, perception, discernment, appreciation, interpretation, and cognizance. What is the role in conceptual clarity? What is the role of this memorizing and understanding in conceptual clarity? Concept, the term difficulty of concept is not completely the inability of a student to obtain pass mark in a section of the physics course, but what constitutes a persistence hitch and makes our job challenging. Students generally have intrinsic difficulty in reasoning, imagining, and understanding basic concepts in physics. What concepts matter? Why concepts matter? Reason is concepts provide definitions. They are useful for covering the course. They are building blocks. They are given in the syllabus. There are marks for concepts in the board papers. They provide reasoning. They provide understandings. They help at every step of our work. Concept map is very important for clearing the topic. We see that every coming topic is related with the previous one. If we interrelate the subtopics with one another and all together with the main topic, we get a concept map. And concept map is very helpful for clearing the concept of a topic. Map, plan and guide. A map is a symbolic depiction emphasizing relationship between elements of some space, objects, regions, themes. A concept map is a diagram that depicts suggested relationship between concepts and ideas. Difference between mind map and concept map. Mind map has a radial structure while the concept map has a structure with many branches and clusters. Mind map focuses on one concept while concept map connects multiple concepts or ideas. So mind map is very important. We need them to track our efforts. Concept mapping and mind mapping are powerful graphic organizers, strategies for organizing and representing knowledge. Both techniques are complementary and help you to develop various skills such as identification of key concepts, pattern recognition, ideas organization, and context understanding. Concept maps are not limited to single hierarchies. In CM, the connections are the most important. This is about concept map. Make a concept map for any one of these. And for this, we should make a group of the learners, and they should be asked to make concept map for one of the topics. Topics are kinematics and laws of motion, gravitation, work, power and energy, electrostatic field, electromagnetic induction, current, electricity, atoms and nuclei, photoelectric effect. Such more topics we can select if number of learners or participants are more. And one thing I would like to say that concept map is very, very important to know each and everything of the topics. Some techniques. Find related concepts using how and why. But we start and go on and on. Teach for fun, not for marks. Marks will follow. जब तक शिक्षा का बुनियादी मकसद नौकरी पाना होगा, तब तक समाज में नौकर ही पैदा होंगे, मालिक नहीं। ये हमारे प्रेसिडेंट ये अबुल कलाम आजाद कहे थे. Teaching physics. When we teach physics, we are involved with knowledge, skills, perceptions that will enable our students to use them in real life. Teaching science is much more than knowledge delivery. Look at this point. Teaching science is much more than knowledge delivery. Very, very good sentence. Education and not literacy. We should not increase literacy of the people. We should educate the people. There is more science in teaching science than science. The essentials. Research is required. We should know our students, up skills. We should use resources. We should plan and implement. Research for content, curriculum, students, our work input and output, resources. We should research on these. Do research, scale up and study effectiveness. It forms a cycle of research and development. Synthesize and theorize, explore, hypothesize and clarify, design, develop and test, implement, study, efficacy and improve. This cycle continues. Example. There are some examples. Graphical analysis of graphs, especially that of acceleration, friction, turns and embankments, motion in a vertical circle, rotational motion, applications of errors in gravitation, thermodynamics, kinetic theory of gases, waves and oscillation, application of Huygens principle, initial difficulty in understanding and Ising and transistor, numericals for work, power, energy, dielectrics, potentiometer, magnetism. These were the generally difficulty people faced. Some faced difficulty in doing the nuclei chapter, but most because everyone did it at the last moment. Rotational motion. Rohan has difficulty in concept of rotational motion, simple harmonic motion, beats, fluids, units and dimension. Units and dimension was not hard as much, but it was very scary when we started the chapter. Feedback from PGT teachers. They get difficulty in laws of motion, the body diagram, system of particles and rigid body rotation, waves, beats and formation of stationary waves, electrostatic force field and potential, electromagnetic induction, application of eddy currents, resolving power of optical instruments and diffraction, semiconductors, and p-n junction. Research. Why research? To check our own work. From rote to fun. Find out the difficult concept in physics in the senior secondary school curriculum as perceived by the students. Make a list of concepts that are not understood from the test papers, exam sheets, viva, class and lab interactions. Ascertain the causes of the identified difficult concept as perceived by the student. This is very important that we should understand the learners. Many phases many challenges we face, like adolescents, aspirations, parents, teachers and themselves, curricular and co-curricular, mighty CBSE board, new vocabulary, tutors, coaching institutes, time management. These are the challenges that we face every day. Map skill related to content and skills. Learner characteristics, assessment, resources. Content, skills, learner support, resources, assessment, and learner characteristics. Important. And we know it. What is important? That we know. Learning is lifelong. We try to teach everything in one day. This should not be there. We should know that learning is lifelong. Patience, honesty, respect for different views are important. There are multiple ways to understand a problem, and there are multiple solutions also to a problem. No solution can be found without full involvement. Learning is lifelong. Upskilling is the process of learning new skills and using them for teaching. Look at this. Methods that we usually adopt in the classroom: lecture method, lecture cum demonstration, lecture cum discussion, laboratory method, observation method, demonstration method, project method, collaboration, coordination, problem solving method. Teaching theories and methods. How to teach. All theories are valid till alternative ones evolve. We should not neglect any of the topics. We should not ignore any of the topics. All topics are important. No single method is the best solution. Good, better, best. Change is the only constant. Getting real, being real, then the examinations. Life after school, admissions, career options, choice of career. Preparing students for qualifying examination, elimination examination, learning to learn, learning to be, learning to lead. Do we need to work hard for conceptual clarity for serious examination? Is it only for competitions? Emphasize on basic conceptual understanding of the content, emphasis on use of SI units, symbols, nomenclature of physical quantities, and formulations as per international standards, providing logical sequencing of units of the object matter and proper placement of concepts with their linkage for better learning, reducing the curriculum load by eliminating overlapping of concepts, content within the discipline and other disciplines, promotion of process skill, problem solving abilities, and application of physics concepts. These are the main points which can help us in conceptual clarity of the topic. So I think this will certainly help you people who are teaching to clear the concept of the students in the classroom teaching. The three components: lesson planning before class, lesson transaction in class, evaluation of lesson in or after class, concept clarity at every step.